Good afternoon, good evening, and good morning, wherever you are around the world. Welcome to today's global webinar on foundation design. And just a very, very warm welcome from the team at Prota. We all have been and continue to be very active working from home. We've also been, as part of the COVID crisis, we've also been upping our exposure to our user bases. It's been really fantastic to see the attendance that we've been getting to a lot of the webinars that we've been putting on over the last a month or two. We've got another really fantastic turnout for today's webinar, so welcome everybody. I'm Nigel Watts. I'm the Managing Director for ProtaStructure. I'm actually based down in very warm Kuala Lumpur. It's been the weather here has been quite hot. It's been a bit frustrating because we haven't been able to get out and enjoy it. But I really hope that today you'll be able to enjoy the session that we've got planned for you. So just to start with, just to go through the agenda for today, I'm going to just talk a bit of background about the Prota Group for those of you who haven't come across us before. I also know that there's a lot of existing clients online as well today. I'm just going to give you some background on that. Then I'm going to talk a little bit about some of the software that you're going to see today. I'm going to take you through the software, and I'm actually going to show you live how you can go about designing and detailing out your foundations. And then we'll close, and anybody who's got any questions along the way, there is a live chat, and you can post any questions that you have as we progress. So Prota's been around for many years, as some of you may be aware of this. We were formed in 1985, and we're actually an interesting mix of businesses. We are not just a software development house, but we're also a large engineering consultancy group, and we do get involved with specialist design. But today I thought, rather than me explaining to you about what we do and what our software does, I thought I'd get the team at Prota to give you that introduction. Okay, so I hope that you're able to pick that up. I do understand that some people were having some issues with audio there, but that was just a little bit of an insight into ProtaStructure, and you heard from some of the team members within the Prota management and development team. So Prota was established in 1985. As I mentioned, it's a group of companies. We actually got an interesting history. It's evolved over the past 35 years. We first started the commercial release of what was then a platform called Prota Orion back in 1991, and that evolved very quickly regionally into a global product that was marketed throughout the world. And then in 2015, we again changed the technology and the platform, and we introduced the ProtaStructure platform or suite of products. And this has also evolved quickly over the last 5 years. We've been growing our user base rapidly throughout the world, and this is culminating in what you're going to see today with the ProtaStructure 2019 version. Aside from doing software development, as I mentioned, we also are a team of professionals. So within our business, we also have practicing engineers, architects who are involved with actually delivering real life projects. We partner other businesses globally, so we work with other professional software distribution firms that support us with locally in their countries with various experts, allowing their user bases to get the most out of the system. Currently, we've got there's literally thousands of people using the platform around the world. It's really fantastic to see people adopting the technology and really making it an integral part of their businesses. We also really are very passionate about software development, and you'll see that as part of that, and part of that endeavour, we also get engaged heavily with research and development into engineering, particularly in earthquake engineering, where we have a lot of experience over many years, and we've published many technical papers in this field, and they inevitably find their way back into the software. So as I mentioned, we're growing. I'm based here in Asia. Our headquarters is actually in Ankara in Turkey. We have a new office that we've just opened up in Europe, and we are growing globally and also partnering many fantastic partners around the world. Now, the engineering side of the business, as I mentioned, is very important to the way in which we shape and deliver the software. Obviously, we also engage actively with our clients, but we've been involved with some really fantastic projects. Recently, we've been involved with delivering much of the metro systems in both in Turkey and around Europe. And we've also been involved with some very large infrastructural projects. Recently, the new international airport in Istanbul opened, and we were involved with the design, the structural design and delivery of that project, which was delivered under an extremely tight time frame. So the technology is being used on a range of interesting projects around the world. These are some airports that have been used, designed within the technology, very large hospitals, campus buildings that have been used within ProtaStructure. This is, you can see the final product there. This is the biggest university in Turkey. And as well as other interesting structures, things like data centers and so on, as the type of buildings that are being designed is evolving, and you've got sensitive facilities like data centers, we're also introducing technology to help support that. So today, I'm going to take you through foundation design in ProtaStructure 2019. Oops, let me just come forward. And to do that, I'm going to be using a couple of platforms. I'm going to be using ProtaStructure, which is our general modeling system, coupled with ProtaDetails for drawing production. On the other side of the coin, we also have ProtaSteel, which you may have just heard about within the video, where we are designing and detailing steelwork connections and producing all the steelwork drawings. And we also have ProtaBIM, which allows us to provide seamless integration with other BIM platforms, including Revit. So ProtaStructure is a physical modeling system, and the way it works is that we work with physical objects to develop models very quickly, okay, and this can be achieved in both 2D and 3D. Once we've completed the model, we can then move into the design, and it will automate the design right from the roof right down to the foundations, and obviously that's what I'm going to be focused on today. This will also produce all the underlying documentation, as well as create all the detailing. Now, to do the detailing, we use two platforms, as I mentioned, ProtaDetails for concrete work and ProtaSteel for our steel. And there's also touched on, we have integration with other platforms like Revit and IFCs. Now, I think anybody who's used the technology will understand that our vision is to make it extremely easy for you to use. And we're also really committed to helping drive productivity. So the whole idea is to make this process from modeling, analysis and design right through to detailing, even down to fabrication, extremely seamless, and really helping you to drive your project productivity and delivery. So for our foundations, so in ProtaStructure, what do we mean by foundation design? Well, in Prota, we're covering a really broad range of different foundation systems. So these can be pile caps, pad bases. We also support strip footings, combined pile, pad, and strip design. I'm also going to touch today on raft foundations and piled rafts. You can also introduce foundation beams into our systems, and we can also look at unique foundations, especially those where you may have to consider eccentricities. More and more people are wanting to also look at how the foundations may interact with the superstructure. And we've also introduced options for looking at soil structure interaction, which I will cover. Now, all these can be visualized. Everything you see today, everything I cover is you can see, you can design, and you can document. So I'm going to take you through that process. Now, for the documentation side, we're going to be using ProtaDetails to show that. And ProtaDetails will just take everything from ProtaStructure and allow you to create all your drawings in one go. So let's get into it. Let's just hop straight into the software, and I'm going to take you through this today. So what I've got here is I've got an existing model in ProtaStructure. This building has already been analysed, and we may have already started designing the superstructure. But I now want to start to move in and look at more detail into the actual foundations. So here you can see that I'm viewing the structure in the foundation plan, and I may want to start the design process for looking at the foundations. Now where might I start this? Well, first things first is I may want to start to look at some underlying geotechnical capacities, and to do that, I'm going to launch Prota Details, and I'm going to start the process of assessing this building by starting this within the Prota Details platform. Now, just give it a moment, and it will launch. Sorry, just give us a moment while it launches. It seems to be now. Okay, so here you can see Prota Details launching. Now, you can run Prota Details independently of ProtaStructure. You do not need to work within the ProtaStructure environment solely. Prota Details can run completely independently of ProtaStructure, and you can actually use Prota Details as an independent drafting tool. But what I am going to do in Prota Details is I'm going to take advantage of some of the design library calculations that we've developed for various component design. And in particular today, I'm going to just take you through pile design. So this might be a good starting point if you're starting to look at foundation design, and you might be, first of all, wanting to look at your piling and your foundation systems and move in and do a quick design of what your piles might be, what pile arrangements, pile capacities might be. So I've chosen pile design here. Now in here you can come and choose different piling systems. You can choose circular, squared, rectangular systems. These can be bored or pre-stressed spun. Board could be driven or excavated. It's up to you. The links can be circular or spiral links. Okay, you have choices here that you can adapt to suit the project. Now, I may want to just start by playing with the geometry here. Let's just say initially I might see if I can get away with a 150 square pile, and I'm going to come in and do some design. So within the pile design module, you can come and specify working loads that you might be wishing to achieve, as well as also performing lateral analysis. Now, I might have a piling system where I'm trying to achieve maybe a working load, allowable working load of maybe 115 kilonewtons. And I may also want to apply some lateral loads to the top of a pile. Now, these shear forces may be due to the reaction from, say, some seismic loading. Okay, you can come in and apply these as effectively as point loads to the top of the pile, and we can consider those in the design of the pile. So I'm going to be checking this for both working load, and I'm also going to perform a lateral analysis of the pile. Now, within the pile design, you have the ability to be able to import soil profile data. So if you'd have been doing a site investigation and you'd like to bring that in, you can import from a spreadsheet the various properties. Now, you can just designate these as sand and silt, clay, and so on within your classifications within the sheet. Later on, you can come and edit individually the properties of those soil parameters. You'd also put in the SPD data as well as the thickness of any particular layer. So once you've done that, you can import this directly into the pile design module, and you can then feed in or look at different design parameters. So within here, we can look at both group efficiencies as well as design parameters in terms of safety factors. Now, I might assume that my maximum size pile cap might be 3x3 pile cap, and because you've got grouped piles, naturally that will affect the capacity of those piles, and there's different ways in which that can be assessed. You've got the converse Labari or the Los Angeles group action, Sela Kenny, there's different approaches that you can take here. I might use the Los Angeles group action, and that's going to give me an efficiency factor of 0.79. So this means that the capacities that we would have because of the grouping of piles together beneath the pile cap would be reduced. So that can be assessed. Now, in terms of the soil data, once we do have this in, as I was mentioned, you can come in and you can play with the geotechnical parameters. So if you want to change underlying geotechnical parameters here, you can. Obviously, we would recommend that if you are working on a project that you do coordinate with an experienced geotechnical engineer who may be able to give you guidance in this area if you're not sure. But you can provide all the detailed parameters can be established in here, and you can add different soil classifications in here, which you can then use in the design. Once you've got those parameters established, we can then make a preliminary estimate of what the working load might be. So we're looking at the shaft friction as well as end bearing, and it's now calculating the end bearing there. Now you can see here I've got 91 kilonewtons. That is a little bit short of what I'm trying to achieve, which is about 115. So if you look at the plot here, you can see for my pile, I'm actually a little bit short. I want a higher capacity, and I'll either have to go deeper in the soil stratum, or maybe I want to just increase the size of the pile. So again, this would be a consideration that you'd need to have a look at. In this situation, I might decide to increase the pile to say 200, and then we can have another go at calculating out the capacities. So you can see now I'm actually up at 131. I might find that seems to be okay. I could at the same time, if I wished, then at this point come back and reduce the length of the pile if I want to really start to refine things. But I might be okay with that as an initial design that I then want to feed into downstream into our foundation design. Now, at this point, you may also want to design the pile section. So what we can do is make an assessment of the lateral spring stiffnesses here, and we're now setting up a soil model with relative stiffnesses for the soil parameters, and we can then run this. So I can run this as a static or cyclical loading. It may be in a seismic zone where you've got earthquake loading, dynamic loading, meaning that the direction of the forces are reversing, and you want to look at a cyclical loading approach. And we can then design this. So we're running an iterative nonlinear analysis to then calculate the forces within the pile. So down this pile here, you can see the moment diagrams. You can look at shear. We'll also give you deflection plots, and you can look and see whether they're reasonable. My deflection there is very nominal, so I'm quite happy with that. We can also look at local soil pressures to see whether they're within reasonable bounds. And we are then going to design the pile section. So let's now design that section, and you can see a schematic of the design here. Okay. Now you can play with this. The reinforcement requirements have been established here, and we could come in and play. So I could maybe reduce the number of bars that I want to play with here. You can manipulate this to suit. I might see if I can get away with a smaller bar. Maybe I can't. I can just play with the number of bars here and adjust this to suit a more efficient design. So you can work with this. We're interactively designing the bars. I might get down to 6 bars there. Links, again, you can play with parameters. You can set up and look at different link arrangements here. You can specify link diameters and so on here to really refine the design. And I might be looking at maybe 13s or maybe down to 10s. So that might be a minimum, an acceptable minimum that I might want to provide within the pile. So you can get down and look at this level of details. Now, we're also providing you the detailed design documentation, okay? And you can see these in terms of reports. So once you've designed this and you're then wanting to document, we can create these reports. So there'll be detailed calculations provided for this design. And you can see all the calculations step by step. Now these calculations, as with the general ProtaStructure system, They can be saved away as PDFs, or you can export these to Office. Now, these calculations also are automatically compiled into the actual project. So you can compile these as part of the other calculations at the end of the job. Now, I might just, at this point, just want to see a detail of how that pile looks. And here you can see we've just come in and created that. So you can see a detailed view of that pile. You'll also get a rough estimate of the steel tonnage there that's being used. Well, not rough, it's a very accurate estimate of it. So there's 157.2 kilograms of steel required for that pile. So that might be a starting point. And I've just used that just to give me a feel for the compile capacities, which I then want to start to look at within ProtaStructure. So I'm going to now take that and take that into ProtaStructure. So I'll just close down Prota Details, and I'll come back to that later. I'm now in the ProtaStructure environment, and at this point I'm going to start the design process for the foundations. So you can see I'm at level 0. This is the foundation level. You can have foundations at different levels. You can assign foundation supports to the ends of columns at different levels and walls. But I'm just going to come and select these peripheral columns here. And when I select them and I right-click, I'm then presented with some options here that I can consider. So I may want to, at this point, design some pile caps. So let's just click on the pile cap design, and it will then load the interface here. So here you can see it's summarized the pile caps that we may wish to design, or the columns and pile cap designations. At this point, we can come in and define our pile settings. Now, if you recall, I was interested in an allowable working load of 115 kilonewtons. I've achieved a little bit more than that, but in here you can come and set the ultimate compression capacity. So what you'll find is in a lot of new or more recent updates to codes, they're moving away from working pile capacities, and they're looking at providing ultimate capacity. So especially for codes like the Euro code, you would need to factor up your working load capacity to an ultimate compression capacity. And a good rule of thumb might be to take what the minimum dead load factors could be, and then multiply that out. So for Euro code, that's typically 1.35. So you could take the 115 that you're wanting to achieve and multiply that by 1.35 to get what would be an effective ultimate compression capacity. Now you could increase that further. This really is around the engineering judgment. Obviously, you also have the live load, which is typically factored higher, and that would be a consideration. But I'm going to work with 150 here. Before I had defined a 200 diameter pile, and I've set the spacing here at 3 diameters. Now you can just come in and manipulate these depending on your piling system, and just come and set these up, okay? And once I've done that, I can then just ask it to automatically design everything. So it's taking that pile arrangement, and it's now designed all the pile caps here. Okay, now these pile caps can be, at this page I can just come and create these. You can group these, so it'll automatically rationalize and group them for you. And then you can just hit OK, and all the pile caps are then automatically created here for you. Okay. Now, if you want to come in and have a look at a pile cap in more detail, you can just select it, and you can interrogate the properties here. Within the pile cap, you can individually play with specifications here. So if you wanted to use maybe a different pile set for a given pile cap, you could. If I wanted to maybe increase the size of the pile for this particular pile cap effectively and the allowable working loads or the ultimate capacities and reduce number of piles that may be required, I could do that. You can also look at different considerations here. So we're designing the pile caps based on rigid cantilever theory. There are other theories that you can use. You can use the GPSS theory. You can consider the effect of column dimensions on the shear, and you can also look at enhanced shear capacities. We will use deep beam theory to design the pile caps, so multiple layers of bars and so on can be considered within the design. And so you can just can choose your considerations here for the design. Okay, the column loads are automatically enveloped for you. Okay, you can split these out and look at individual combinations if you wish, or you can just look at the particular envelope. Now you might notice there that there's also an option to have user-defined loading. This can be run here. You can also run the PileCap design and Prota details. So if you're just wanting to do a quick PileCap design by itself, you can apply your own loading here. So you can just set this up and easily come in and define what's important to you. Okay, so we will then check the pile capacities against allowable. So if anything's exceeded, you'd see this here. And we will then come through and perform different design checks to ensure that the results are designed. Now, which is often the case, you're on site and you may find that piles don't actually end up where you want them to be. You can move these around. So here I'm just typing in eccentricities on site, okay, and I could just key in any eccentricities that may have occurred, and you can see that instantly we're also checking this to see whether that's still okay. So in here you can provide in any piles that may have on site may have moved away from where they're meant to be. That can all be defined here as well. Now I may want to just come and create a quick report of the pile cap at this stage, and you can just produce that. So again, everything will be clearly documented here, and again that can form parts of the reports into the final report within ProtaStructure. So if I hit OK, you can see there that it's now providing you with the actual as-built pile cap design, okay, together with the other ones here. Now there are other foundations in here that I'm going to show you. So if I come over and click on this here, I might at this point want to insert a pad base. We can come in and just key in basic parameters here. Okay, you can play with the allowable stress on the soil. You can also define surcharge heights, which may be, obviously you're excavating down into the foundation. If you want to add some soil surcharge on top of that, you can. Okay, and then we will then design this for all the different combinations that may be acting on that foundation. So if you just ask it to calculate, it will then optimize the size. Now the sizing can be either rectangular, as you can see here, or you can have square. And you can also play with things like eccentricity. So if you have maybe a column that's closer to the edge, you can just adjust things and tweak things to suit. Okay. Now, if you're happy with this, we've done the design, we've sized up the reinforcement. If you then hit OK, that foundation will then be created in the model. Okay. And then you can see that that's been now applied. Now, another common foundation type may be combined foundations. And if you've got two elements that are very close together, as you can see here, I've got a couple of columns which are only a short distance apart. I can come and grab these columns, so I can select these two columns here, and we have the option to combine these for shared foundation design. Now at this point, I can then come in and choose to insert maybe a pad base or a pile cap, and we will then resolve the forces into a combined foundation, and we can ask it then to design this. So I'm just going to run the design. Okay, I'll run design selected, and you can see that this is now designed that foundation. Now I may want to play with the capacities. Let's maybe increase it and see if I can redesign that. Okay. But what you can do here is you can play with this. So if you find that you don't want to use 3, that might not be suitable for this particular foundation, maybe I want to end up with 4, I can. And if I just hit OK, you'll see that it's now come and created that combined foundation beneath those two elements. Similarly here, let's come and grab these two columns, and I'm going to combine them. And if I right click, I'm going to insert the pad base. So this time round, again, we can ask it to calculate. It's combined all the forces for us and resolve these, and then it's done the design. And then if I hit OK, you'll see that it's then designed a combined pad base for this particular foundation. Now, another common foundation type that you may come across is a raft as a strip footing. And the way we go about setting up strip footings within the system is to give first of all just import a beam. So this is what we would call a foundation beam. You can just use foundation beams to tie foundations together. Maybe you've got a foundation with eccentric loads and you need to introduce a foundation beam, and you can come and draw a foundation beam in. Once you've defined a foundation beam, you can then use this and right-click and create the. You can then come and right-click. Sorry, let me just close that down. Once you've got a foundation beam in, you can right-click here and you can then have the option to insert strip footing. So it's now going to load the strip footing design. Whoops, let me do that again. Okay, so in here you can see there's a little design module here for strip footings, and in here you can come and define different spring stiffnesses beneath the strip footing. You may want to consider an envelope of spring stiffnesses beneath a foundation, and you can do that in here. So I could step through a range of different spring stiffnesses here, and these can all be considered as part of the design. So you may have it ranging from, say, 15,000 kilonewton per meter cubed, right up to, say, 50,000. It's up to you. Or if you're very comfortable with the geotechnical spring parameters, then you could just use a fixed amount. Now, you can have slightly eccentric footings if you wish. You can also take advantage of tapering, and the tapering can occur both in the strip footings here, or maybe within a pile cap, or even a pad base. So you can define tapers in here. Now I'm going to design this for the whole envelope, and I'm going to then ask it to design. So it's now taking the forces that are in those columns, okay, the envelope of those, and it's then designing this. So this is based off the envelope of forces that we have, and that's designed. And if I just hit OK there, you'll see that it's now come and designed that foundation base. Now, progressively, as I've been doing these, you may see that these foundations are also being shown in 3D in the model. So you can just come and interrogate these and make sure that you're happy with what's being provided there. Okay, so there's my strip footing. You can see the combined foundations there, as well as the various pile caps that we've created so far. So at any point, as we're going around and designing these foundations, everything within the model you can visualize. Now, another foundation type I'll touch on is Raft Foundations. Now, you might see here that I have a lift core, and I've got actually two shear walls quite close to one another. And to effectively provide an effective foundation solution for these, I may want to consider introducing a raft. So to do that, I can take advantage of tools just to help me sketch out a profile for a raft. So you can see here I've come and defined that, and we can then come in and define a raft thickness. So I'm going to let's consider a raft thickness of, say, 500, and we can then place that beneath the wall. If you see this in the 3D model, you can see that we've now positioned a raft directly beneath the lift cores there. Now, to effectively design rafts, we will take advantage of using finite element analysis. And what I'm going to do here is I'm going to cut some what we call integral strips through the raft, and I'm then going to mesh the slab and use finite element analysis to help me with the design. So you can come in here and define FE strips, and I'm going to choose to define an integral strip. Now, the width of the integration you can consider here. I've got this set up at 1 meter either side. This is entirely up to you. You can come and choose parameters here to suit. And I can then just cut strips through this foundation here to use to help me integrate and interpolate the results along those strips. Now, you can define the strips in both X and Y. If you do choose these, because we will automatically adjust the effective depths accordingly. So obviously you've got the foundation bars being layered on top of one another, and your effective depths in different directions will vary. So we will take consideration of this when we are designing those foundations along those different strip lines. So I may just wish to cut a few strips here. You can see I've cut 3 strips through this, And at this point, I'm going to move in and we're going to run the FE Raft Foundation analysis. So in here, you can come in and choose your subgrade coefficient. Now, if you're not sure here, there's handy guidance from Bowles that you can consider. So if you're not sure about the properties, maybe as a preliminary start, you could just base it upon the underlying material. Obviously, if you've got a geotechnical report, then you could key in those values. Depending on what type of foundation it is, would depend on you may want to consider other things here. So if I had piles beneath this as well, and I don't wish to consider the soil spring stiffness, I could remove the soil model and I could have a suspended foundation system here. You can also, if you want more efficient design, include the boundary of the columns within the model here. So it will mesh to the face of the columns and you'll end up with a more efficient design. It will help reduce peaks that may have otherwise occur within the finite element analysis. You can also take advantage of reducing live load. So if you did want to take advantage of live load reduction here, you can. That's not normally the case, but if you did want to consider that, you can do that as well. So at this point, I'm just going to ask it to mesh, okay? And it's going to take this this foundation, and it's going to load the meshing preprocessor. So you can see here, it's provided that you can play with the plate element size and uniformity here, and then you can ask the system to create a mesh. So you can see while it's creating the mesh, it's also automatically establishing the soil springs beneath the foundation here. So those soil springs will be based off the parameters that we had pre-selected before. Now you can go in individually and change soil spring stiffnesses beneath individual panels within the foundation system. So if you have varying spring stiffnesses across a site, those can also be catered for within the model. Now if I just close this down, it's now going to move away and run the finite element analysis. And again, it's considering all the different combinations from the superstructure above, and then these are being run in the analysis. Now that's done, and I can now move in and we can take a look at the results. Okay, so it's loading the FE post-processor here. If you move in here, you can see various contours here. So I'm just showing you at this point the deflected shape of a slab. And you can see from the range of values here that the maximum displacement we have there is about 9 millimeters. So, and that's based off my dead load combination. So I may be okay with that. Obviously, you can use this just to get a feel for behavior at this stage. At the same time, as we are looking at the displacements, we're also calculating the moments within the slab. So here you can see the moments in the X and Y, and the torsional moments or the wood armor moments are also being calculated within the slab here. Now we automatically will resolve these into X and Y. These torsional moments will be resolved into X and Y for design. And you can look at moments both in the top as well as the bottom. And what we also do is based on an effective depth, we will also give you a feel or an idea of what type of reinforcement you may require. So if I look at this, let me just look at this in plan. So if I'm looking at my peak moments there, I need about 2,500 square millimeters, but obviously using FE analysis, we can take advantage of interval strips and we may be able to bring those peaks down. And I can look at top steel here, and you can see the range is up to about 1,296 millimeters squared per meter width. And I can look at these in different directions. So this is just giving you at this stage a feel for what's required in the design. Okay, just at a glance. Now you'll know that I cut those strips earlier, and these strips can then be resolved. So I just chose to look at the strip along the X direction here, and you can see the moment as well as the design moments being established here. You could look at displacement as well. The design moment is, as I said, the torsional moments are being resolved here, and you can also get a feel for the required area along that strip. Now we are integrating across those strips, so you'll see that there's a red dots in the middle of that strip, but we're not taking those values. We are taking the integral result. So we're averaging the moments across those strip widths. Okay. Now, based on the moment diagram, you may want to reposition your integral strips. It's entirely up to you. Okay, you can place these wherever you like. Okay, you can have as many strips as you like through the foundations, but this just allows you to then drive the results along those strips to make some assessment of those design parameters. Now, the last thing we may want to look at is our soil pressure. Obviously, allowable bearing pressures and so on is important, and you can come in here and set up user-defined contours. So if you had a maximum limit on the bearing capacity in the soil, you could come and set that in here, and that will give you a feel for whether that's being exceeded or not. Now, for my Raft Foundation there, I set 300 there. That seems to be okay. You could, of course, change this, and you can just get a feel and bring that limit down to see whether any parts of that are exceeded. And I get down to 200 there. You can see that these parts of the foundation there are where the most stress is being accumulated. Now, and that may give you some feel for whether or not a Raft foundation may be satisfactory in this situation. Maybe you find that the bearing capacity is exceeded and I need to look at another alternative. Okay, so this will just give you some idea of that in here. Now, same time, what we're also doing is we're also meshing other elements within the foundation. So you can see that we're meshing pile caps here, and we also provide you with the forces for the piles within these meshed elements. So you can see a range of forces within the pile cap arrangements here. Because we use rigid cap theory for the design of pile caps, and we're assuming cantilever theory, we don't typically take these, we don't take the finite element results. What you tend to find is with FE, if you have a column and you have a pile directly beneath that column, and then other piles may be radiating out from that, the pile beneath the pile cap, because it's a flexible meshed, will attract more load. Okay, and that's not always ideal and what you'd like to achieve with, say, a pile cap design. So we don't typically use these for here, but if you had a very irregular pile cap shape, you could define that, you could define the piles within that, and then you could use finite element analysis to consider the design of that. So at this point, I'm just going to close this down, and we're then going to transfer those strip results back into ProtaStructure for the design. Okay, and it's just now transferring the results across. Okay, they're all being played into ProtaStructure, and we can then look at the design and detailing of these. So just give it a second. You'll see that this is passed back in, and we can then look at the reinforcement requirements. So within here, I can just come in and update the steel bars, and you'll see that it's designed the bit reinforcement across those strips. Okay, and you can see the requirements here that we have provided. Okay, now if I come and select this foundation, part of the foundation process may also be to run punching shear checks. So in here you can come and choose to run punching shear checks. Baseline reinforcement here can be set, and then you can ask the system to perform a design check of that foundation. Okay, now we're checking the longitudinal bars here, and then it will check this, and then it will provide you with a report which you can see whether the punching shear checks have satisfied the code. So we're checking both beneath the face for local bearing, as well as for Eurocode 2D out from the face, and it will advise you whether any additional shear steel may be required. I think I've got a situation here where maybe I need to provide some additional shear for the wall W1, and that could be introduced as additional longitudinal steel, or you could look at introducing studs or shear links into the raft. Okay, and the value of that, the requirements of that are indicated on the drawing here. You can also see the shear perimeter which we have checked for that particular wall. So that gives you an idea about how you might go about designing a raft. I can also, if I found that this wasn't working, you can also select any raft within or any foundation within the software, and you do have the option to insert piles. So you can come and define piles within the raft. You can set up and create a pile arrangement, and you could predetermine these in the model here. So if I hit OK, you'll see that I've now predefined an arrangement of piles beneath that raft. And you can work with these piles just to create whatever type of piling system you want. So if I decided that perhaps these piles here, I don't want to see them, okay, I'm just going to remove those piles. I can then come and play with a custom arrangement of piles here. And these are all editable, so all the properties here you can manipulate to suit your requirements. So if I need a bigger pile, maybe it's a square pile, I want to move it around and maybe increase the capacities, that type of thing can all be done here, and you can just adapt this to suit your foundation systems. So within here, you've got a lot of flexibility to be able to create virtually any type of raft foundation, any type of piled raft can be set up within here, and you can create any type of foundation geometry. Now, at this stage, before I get into looking at the documentation, I may just want to come and create a quick report. Okay, we will automatically compile reports within ProtaStructure, and you could just maybe specifically look at a foundation report here. So you can just see there it's building that out, and all the design that we've just done can then be fed into a report here. Now, I'm just going to remove here, and you'll notice in the report here that I can just come and grab and introduce the various parts reports that I want to show. So maybe the pile reinforcement design, the foundation beam reinforcement design. Okay, these strip footing design. These can all be organized into a report. Okay, and then we can then view that report. So ProtaStructure will automatically build this into a single report that you may wish to create for the foundations here. So just give this a second. You'll see that this has now built the report out. Okay, and you can just come through and look at different parts of the report. You might be looking at the pile design there, or maybe the pad foundations, the combined foundations. Okay, will be provided. Well, here I've also got my foundation being designed as well as my strip footing. So all of this is nice and neatly documented. It's all compiled automatically into the report here, and you can just bring this all together, and then you can document that out to PDF or to Office. Now at this point, let's get out and just start to publish information out. So to do that, I'm going to load Prota details. Okay, and just give it a second. It's just going to save, and it's going to launch Prota details, and then we can then start to create all our other documentation, which is our drawings. Okay, so once we've gone through, designed our foundation systems, we can then move out into Prota details, and we can start to prepare all our drawings for this. So I'll just grab a quick glass of water here while it's loading. Excuse me, my throat's getting a bit dry. And you can see that that's just loaded. We save all the data before we go to Prota details, just to make sure that you're using the latest version of the data, and then it will then launch. So you can see here it's just automatically launching Prota details, and we're going to move into looking at the documentation now. So in here, you have the ability to be able to automatically generate all the details out. This is working in DWG. I'm just going to come and choose to automatically generate details. And here you can choose what you want to draw. So I just want to focus on the foundation. So I'm not going to draw other parts of the structure. I want to draw the form plan or the foundation plan. And I'm just going to turn off these other items here. So I want the form plan, and I also want these other foundation drawings created. Now these can be automatically inserted to your sheet, and you can just come and predefine title block here. Now, you can come and set up different parameters. So for the sheets, you can create naming conventions. I may want to call this bottom drawing here foundation plan. Okay, it's up to you. You can just come and set that in here. And you can play with other things like scales and details and so on can be set here as well. At this point, I'm just going to ask it to draw. So I'm going to take that that detail out, and then Prota Details is now going to come and prepare that foundation plan for me. Okay, so you can see here very quickly it's created those drawings. If I zoom out, you can see that all the different drawings there and details with the associated foundations have been created. If I move into our foundation plan, here you can see set out. So we are defining set out against grid. Okay, so this might be very useful for construction when you're laying out things on site. And you can see the various references to the pile caps there. Okay, you can see our plan views here with reinforcement for the raft being laid out, combined foundations, as well as our strip footings there. And then these are then subsequently documented. So you can see, say, our plan base here with all the reinforcement in it. You can also look at our pile cap design here, okay, and all the reinforcement is then provided in here. Now, do just remember that these are, we're actually in CAD, and if you do click on any objects in here, you can manipulate the detailing here. So if I just say, for example, I was interested in just in maybe manipulating the label here, I could, come in, let me just get in a bit closer here. You can just come in here and you can work with different objects to move them around. So if I wanted to move that dimension mark a little bit, I can. So all of everything that's presented in here is fully editable. You're in a CAD platform and you can just come and make changes as you wish. Okay. If I wanted to pick up perhaps these foundation details here and I'd like to move them around to another part of the drawing, then I can just reposition these accordingly. Now, if you would like to create other details, you can individually draw these out as well. So if I just right click, I can choose to draw pile caps one by one, and I could draw these off to the side here, and you can see I'm just coming in and drawing out the those pile caps again as well. So you can selectively choose to draw a pile cap or multiple pile caps out from the model here. Now you'll remember that I moved a pile around, and let me just find it. I can't quite find that, but what you'll see here is that I've drawn these out. But what you can also get here is a summary of the pile coordinates. And earlier you remember that I did create a drawing where the pile was eccentric, and the as-built coordinates can also be shown here. So you can draw those up in here and provide that level of information to. I think that's here. So you can see where the original pile position was and where the as-built coordinate is, and those coordinates will be indicated in the table here. So that's very useful for providing as-built information. So that gives you an idea about how you go about taking that information from ProtaStructure and then creating all the underlying documentation within Prota Details. And the final thing I'm going to touch on today is just a final consideration. You recall that we had created a complete model here, and now that I've done the initial design of the foundation system, I may wish to consider or look at soil structure interaction. So to do that, we can repeat the building analysis, and when we do this, we do have the ability now to actually combine the foundation model with the superstructure. So what we're doing is we're taking the analysis model of the superstructure and we're combining it with the foundation analytical model, and then we can then run this. So we can run this again, and now that the superstructure is being automatically combined with the substructure. Now what we don't do at this point is we're not building out a soil model for the piles. So we're not putting all the piles in and providing lateral springs at this point. That may be a future enhancement that we look to introduce. where we start to create a more sophisticated substructure model. But at this point, you can just combine these two together and you can get a feel for the global behavior of the structure when the foundations are considered together with the superstructure. So just give it a second. It's just going to launch and it will run the analysis, and then we can have take a quick look at these results as we conclude. Now the beauty of this obviously is that everything is self-contained within the one model. So right from the superstructure or the steel concrete work, everything right down to the foundations can all be designed in an integrated fashion. So if you've seen some of my other presentations where I've been looking at other parts of the design process, all of this is completely integrated, and it's the vision that we have for the product. So everything's self-contained within the one model, and right from the roof right down to the foundations, we're considering all the design in an integrated fashion. Okay, so this is now run the analysis again, and this time around I've integrated the foundations together with the superstructure. Okay, and then once we've done this post-analysis, we can take a look at the results here. So I'm just going to load the model, okay, and we can then come in and interrogate those results. So this time around, you'll notice that the foundations are now meshed, okay, and we have used springs beneath the foundations. We don't provide the pile springs, as I mentioned earlier, okay, so you think of this a little bit like a big raft, and you can then interrogate the behavior here. So if I wanted to look at the results, maybe I'm interested in the global resultant displacements beneath the model, you can come and interrogate this. You can see there's quite a bit of data there, okay. We can animate this so you can get a feel for the behavior, okay, and you can see the structures moving up and down. You can also take a look at a, I could potentially turn on contours here. We can also see a range of in this case, I might be interested in displacements. So let's just look at a range of displacements there. My displacements in this scenario are not particularly large, okay. They're only a few millimeters. So there's a range of different displacements there that are being recorded. Okay, and I think I might have to put that on delta Z to get that range. Okay. So this just gives you an idea, and this just shows you how you can integrate the superstructure and the substructure together just to get a feel for the global behavior of the model. Traditionally, of course, you would have designed the superstructure separately from the foundations, applied those reactions at the foundation level, and then move through the foundation design. But with ProtaStructure, you can also consider this if this is something that's important to you. Okay. So that just concludes what I was going to talk about with the foundations. I just want to just some summary comments as we finish off, and I'll also look to answer any questions that you may have prompted during the course of the presentation. So obviously we've covered quite a bit of ground. We've looked at a range of different foundation systems here: pile, pad, strip. You saw combined foundations, piled rafts. We also looked a little bit at soil structure interaction. I didn't get to looking so much at foundation beams, but they can all be modelled in the structure. You can take advantage of those. You can also define irregular foundations, and foundations can be defined at different levels, as you can see in these views here. And finally, then we moved in to document everything. So you saw how those were then created within Prota details, and how you can just extract what you want from the model out into nice and neatly arranged drawings together with all the quantities takeoff. Now we do provide all the quantities, all the rebar takeoffs, all the breakdown of all the quantities is provided, and you also saw how we went about creating all the design calculations here. Okay, so that can all be organized into nice, neat reports, and they can include your company logos. They can be set up to look like your calculation sheets. So I just Obviously, the software, we're really privileged to have a real fantastic user base. It's growing rapidly around the world. We've got some quite iconic names in the engineering industry actively using the software. We're very grateful, and we're also, it really is fantastic to see the software being used globally now. Just to introduce you to some of the projects that have been used in the software. These projects are actually some very large malls here in Malaysia that have been designed within the system. Again, they're designing it from the roof down to the foundations. Projects in London here, interesting projects in Hong Kong. So the software is being used on quite a diverse range of mix of projects around the world. Okay, and the key around all of this is obviously helping you to become more productive. So I'm hoping that what I've shown you today is sort of has helped give you some understanding of how you may be able to take advantage of the technology. Now, the great thing about ProtaStructure is everything comes complete. Okay, we don't modularize it. You don't have to buy 4 or 5 different applications to get an semblance of some sort of solution. Everything comes together. It's all integrated. And what we're trying to do is provide this end-to-end solution. So going right from modeling, analysis and design, right through to drafting, production, all your drawing management, all the component design, quantities and schedules, right through to things like steelwork detailing, connection design, even down to fabrication drawings. Now, BIM is also becoming incredibly important, and we've got really fantastic integration with other BIM platforms, including Revit and other leading tools like ArchiCAD and Allplan. So you can also take advantage of that because we create a physical model from the outset. So this is what we offer as a platform. This is the vision that we have for the system, a combined integrated platform that you can take advantage of. I hope you like what we covered today. We are continuing to invest significantly in ongoing development work. It really is a fantastic time within the evolution of our business. We do have other events coming up, and I'd love if you can join us for those. So for those of you who are interested, we have ProtaSteel, a new seminar coming up on ProtaSteel, and we're going to focus on our intelligent, I guess, AI IntelliConnect platform for connection design. And we're also going to look at engineering and fabrication drawing production with that. And Artik, who's our ProtaSteel product manager, will be delivering that on the 13th of May. On the 20th of May, we're going to visit a more detailed performance-based design, and this time we're going to have a bit of a focus on retrofit design. For those of you who are actively doing seismic design, and you are interested in looking at how you may be able to rehabilitate existing structures, you can tune into Mustafa, who's going to be talking about the innovations that we've been making in this area. I'm going to return on the 3rd of June, so you can listen to me again, where I'll be presenting flat slab design. It's another really powerful part of the platform that we have. So for those of you who are interested in flat slab design, please join me on the 3rd of June. And finally, on the 24th of June, we've got something really special coming up. And if you could mark your calendars for that date, please join us, because we have really fantastic global launch of our new platform that we've been working on now for the last couple of years. So this is something that nobody's seen yet. It is we're advancing the technology significantly, and we're really excited about this. So mark the 24th of June. This is the global launch of our 2020 platform, and we'd love to have you along for that. Also, I'd just like to thank you for attending today. To our users, thank you for your continued support. It really is fantastic. We love hearing from you. Please visit us through our support channels online. Contact us directly or through your local dealer. We're more than happy to help you with any questions that you have on using the software. For those new to ProtaStructure, we do have some very special offers on ProtaStructure, the 2019 suite at present. This is back with direct technical support and all updates, so I'll include the new 2020 release. Okay, and these are really fantastic prices just to help clients through this period. So if you are interested in this, please approach us. There's a couple of email addresses there that you can reach us at: globalsales@protasoftware.com or asiasales@protasoftware.com. Okay, or you can visit us at our website. Do go and have a look at the website. There's a lot of useful information there that you can take advantage of, and you can also connect with us. To follow us, we are online, so we do actively participate through Facebook, LinkedIn. So if you're wanting to find out what we're up to, updates and the like, do connect to us through those channels. Finally, I'd just like to thank you for today. I hope you enjoyed it. I did cover a lot of ground. If you've got any questions for today, please let me know. And on that note, I will just come in and answer a few questions that people have. Okay. Okay, so I'm just looking at some of the questions that people have loaded today. Okay, some of them, sorry, most of them have been answered. So, so thank you for your attention today. I hope you enjoyed it. Please feel free to feedback on the exit poll, answer those questions. It would be great to hear what you think of today's presentation. Thank you very much, and we'll see you again very soon.